Okay, good evening once again, children. I've shared my screen. Is it visible?
Yes, ma'am. Visible.
Okay, Harini, you can see my screen?
Yes, ma'am.
All right, fine. All right, children. So this is chapter 5 from the NCERT Maths textbook, which is called Lines and Angles. Lines and Angles. All right. So before we actually start working the problems from this chapter, we need to get familiar with certain terms. Okay, so let's understand those new terms. We are about to see some new terms related to lines and angles. We'll understand the meaning of those terms and then start working the problems in the exercise. All right. Okay. Now first, what is the point? So we all know what a point is, but how do you express it? Okay, if you're asked the question, what is the point? A point is a location represented by a fine dot. So this is what you do, no? Point. A point is a location. You say that something is here, something is here, something is here. So a point is a location represented by a fine dot. You should not mark a point like this. In the diagram, of course, you can see it's very bold here, but actually it's not like that. Here you see it's like this. You should not make such a big thing. It's not like this. It's a fine dot. It's a fine dot. So see here, A, B, C, point D, point E. So here you can see that the points in my figure, you can see that the points A, B, and C lie on this line. But the points D and E do not lie on the line. They are outside the line.
Ma'am, we call it something exterior. What's that called? Exterior?
That is with regard to a circle. That's okay. Fine. A point does not have any length, width, shape, or size. It only has a position. Remember all this. A point does not have any length. A point does not have a length. It does not have a width or breadth. Okay. So shape, size. It has only a position. It only has a position. When two distinct points are connected, they form a line. Two distinct meaning two different. Okay, see, supposing you have a point A here and you have another point B here. When you connect these two distinct points, they form a line. Points are denoted using capital letters. Points are denoted using capital letters. So when you mark a point, you should not call this point A. It's not represented by the small letter A. Okay, if you want to name a point, you must use capital letters. Capital letters, A to Z, capital letters, not small letters. So a point is a location represented by a fine dot. It does not have a length or a breadth. It only has position. And when you connect 2 points, you can even connect 2 points like this here. When you connect these 2 points, let me draw this. Okay, so when you connect point A and point B, when you connect these 2 points, you get a line. You get a line. And points are denoted using capital letters. Now, next is the line. A line is one-dimensional, or a line is a one-dimensional figure, and it extends indefinitely on both the sides. We know that. A line has no definite length. A line has no definite length. These are some features of a line. These are some features of a line. Okay, a line does not have any definite length. A line is one-dimensional. It extends infinitely in both the directions. There are infinitely many points lying on a line. So when you take a line, there are infinitely many points, many points. There are infinitely many points lying on the line. And how do you name a line? If you have a line like this without any name, there's a line like this. Okay, there's a line like this. It does not have a name. You want to give a name to this line. So what you should do, you should take 2 points on this line. You must take 2 points on this line. Take a point like this. You can call it P. Take another point. Call it Q. Now this is line PQ. Line PQ. This is line PQ. I'll tell you again. Supposing there is a line. There is a line. It does not have any name, but you want to give a name to this line. How do you name the line? Take 2 points. Take 2 points on the line. Say M and N. So mark a point on one end, mark a point, give it a name. So this point is represented by M and another point on the other end. And I've called it N. And you know that you should use only capital letters, not small letters for points. A point is always represented using a capital letter. Now this line, the name of this line is line MN. Line. This symbol represents line. Line MN. Now there's another way. There's another way to name lines. There is another way. What is that other way? Instead of taking 2 points, you can also name it like this. This whole line, you can give it one name. That is line L, line P, line Q. Now this should be only using small letters, not capital letters. If you name the line like this, line M, then you should not use capital letter M here. Line M, small letter M. So there are 2 ways to name a line. One way is take a point, take another point, and the name of this line is line AB. This is one method. Or line, simply write a small letter outside the line. You can write it here also. This end or this end. You can just take a small letter outside the line. So this is line L, line L. Or on this end, you can write M and say line M. Only one letter you should use. Only one small letter. Okay, so line S, line S, line P. Okay, so these are the 2 ways in which you can name lines. Line segment. So you know a line segment has 2 endpoints, right? A line segment has 2 endpoints. There's a starting point, there's an end point. So a line segment is also one-dimensional. That means it has only length. It does not have breadth or thickness. Line segment is one-dimensional. See, a point has no length, no breadth, no thickness, nothing. A point does not have a length or a breadth. That means a point has no dimensions. A line and a line segment, both are one-dimensional. Both line and line segment are one-dimensional. That means they have length, but no breadth or thickness. And a line segment has 2 endpoints. Now, how do you name a line segment? So these are the 2 points. These are the 2 endpoints of the line segment. So if it's a point, capital letter. If it's a point, capital letter. So this is the line segment PQ. The 2 endpoints are P and Q. The 2 endpoints are P and Q. So maybe line segment AB. Line segment AB. So A is 1 point and the other point is B. A and B are the 2 endpoints. A and B are the 2 endpoints of the line segment. And it's written like this, line segment AB. If it is line AB, it will be like this, line AB. This is line segment AB. Now, what's a ray? What is a ray? A ray has a starting point and it extends indefinitely on the other side. A ray has a starting point. It starts from somewhere and it extends indefinitely on the other side. So maybe it starts here and it goes indefinitely on the other side. So if it's going indefinitely, we represent that side using an arrowhead. If it's going on indefinitely, we use an arrowhead to represent that side where it is extending. So a line has a a ray has a starting point. A ray has a starting point. So maybe it starts at A and it extends indefinitely on the other side. So take another point and this is ray AB. This is how you write it, ray AB. Ray AB or ray PQ. Ray PQ. So it has a ray has an initial point. Here the initial point is P and it extends indefinitely on the other side. Now, what are collinear points? What are collinear points? Now, supposing you have 3 points and you can connect all these 3 points by the same straight line. If you can connect all the 3 points by the same straight line, then the 3 points A, B, and C are called collinear points. Collinear. Linear meaning on a straight line. Linear meaning on a straight line. Collinear points. Now, supposing you have 5 points. 1, 2, 3, 4, 5 points. And if you can connect all the 5 points by the same straight line, then these 5 points P, Q, R, S, T are called collinear points. Collinear points because all the 5 points lie on the same straight line. See, these are not collinear points. Supposing point P, this is point Q, this is point R, this is point S and T. Now here P, Q, R, S, T, they are not collinear. They don't lie on the same straight line. P, Q, R, S, T, here they're not collinear. Here they are collinear. In this one, they are collinear. They lie on the same straight line. Here they are not collinear. So collinear is about 3 points or more than 3 points. For collinear points, you must have at least 3 points. 3 or more than 3 points are said to be collinear if they lie on the same straight line. 3 points or more than 3 points are said to be collinear if they lie on the same straight line. Non-collinear points. So you can see here 1, 2, 3. Now supposing you want to connect the points A, B, and C. A, B are able to connect, but C is, you cannot continue with that line and connect C. Or when you try to connect A, B, and C, what is happening is, when you're trying to connect A, B, and C, you connected A and B, then you're going in the same direction, but C is somewhere below. It's not on the continuation of the line. You don't meet C as you continue. C is away from the line. Here A, B, C are not collinear points. Here A, B, and C are not collinear points because anyways, maybe you can connect A and C, but you cannot connect it with B. See, A, B, C. See, maybe you can connect A and C, but B is outside the line. So 3 or more points are said to be non-collinear if they don't lie on the same straight line. I'll give you the notes later, so don't worry. So far we have seen point which has no dimensions, line and line segment, which is one-dimensional. It has length, but no breadth or thickness. Point is always represented using a capital letter. Then after point, line, and line segment, we saw ray. It has an initial point and extends indefinitely on the other side. Then we saw collinear points, non-collinear points. If 3 or more points lie on the same straight line, then they are collinear. If they don't lie on the same straight line, they are not collinear. Okay. Now, what is an angle? Okay, what is an angle? Now, an angle is formed when two rays, they come from the same point. Now, supposing there's a point here. Okay, we'll say a point A. Now, a ray is coming out through this point. Another ray is also coming out through that point. So when two rays emerge from the same point, then an angle is formed. Then an angle is formed. Supposing there's a point, and from this point there's a ray. Because what is a ray? A ray has a starting point, and it extends indefinitely on the other side. It goes on and on the other side. So let's take this point, and there is a ray coming from this point. Another ray also comes from the same. Now, when two rays start from the same point, then an angle is formed.
Ma'am, I have doubt.
Yes, Anirudh?
Ma'am, like in the figure they are saying one is ray and another one is the arm of an angle, ma'am. But it is also in ray only, no, ma'am, because it starts from one point and is extending to the other end, ma'am.
No, you have not understood the diagram correctly. It's given that this one, see, can you see rays? That means these two are called the rays. And these two are called the arms of the angle. They are called the rays. That's the meaning. Because you can see the plural here, rays, arms. They can't point to this one and say arms.
They are saying these both lines are called rays and arms.
Correct. Both of them. This is a ray. This is also a ray. Now, when we are talking about this angle, for this angle, this is not a ray. For the angle, this is an arm. This is the other arm. In general, this is a ray. And this is also a ray. Why they are rays? Because they start from this point and they're going endlessly in the other direction. So both of them are rays. But now when this angle is formed, for this angle, this is one arm, this is the other arm for the angle.
Okay, ma'am.
For the angle, this is one arm, this is the other arm. Okay. So I was telling you that an angle is formed when two rays start from the same point. So there is a point, one ray starts like this, another ray like this. So an angle is formed. The angle is formed between the two rays. Now this is the angle. This is the angle. For this angle, this is one arm, this is the other arm. For the angle, this is one arm, and this is the other arm. And supposing this point is O, let's take a point on the ray A. Let's take another point on this ray B. So the angle is called angle AOB. Angle AOB. Angle AOB.
Ma'am, the word in the middle, ma'am.
Now the point from where the rays originate is called the vertex of the angle. The point from where the rays originate is called the vertex of the angle. And when you name the angle, you must put the vertex in the middle. You can call it AOB or BOA. The vertex of the angle should be in the middle. This angle can be called angle. Put the vertex in the middle. Vertex is O. Put that in the middle. So you can call it AOB or angle BOA. So this is the point from where this ray and this ray start. Now, when two rays start like this from the same point, an angle is formed. Now, for this angle, this point is called the vertex. Now, for this angle, these two rays are called the arms of the angle. For the angle, this is called the vertex. In general, it's a point. In general, this one is a point. But for this angle, this is not just a point, it's its vertex. In general, this is a ray. This is the other ray. But for the angle, they are not just rays. They are the arms of the angle. And how do you name the angle? Now, supposing, so for to name this angle, you need to take a point on this ray, and mark the vertex. Mark the vertex of the angle. I've called it R. Then take a point on one ray and the other ray, or one arm and the other arm. Now the vertex is R. Put that in the middle. So the angle is angle PRQ, or put the vertex in the middle, QRP. Okay, so it is PRQ or QRP. Now, complementary angles. Now, when we say complementary angles, we are talking only about two angles. We are not talking about one angle or three angles. We are talking about two angles. When we say complementary angles, we are talking exactly about two angles. Two angles are said to be complementary if their sum is 90 degrees. Two angles are said to be complementary if their sum is 90 degrees. Now you can see the angles here. You can see there's one angle here which measures 30 degrees. There is another angle here which measures 60 degrees. Now what is 30 plus 60? It is equal to 90 degrees. 90. So this angle and this angle are complementary angles. You can see a question there below. Are these two angles complementary? Yes. Why? Because they add up to 90 degrees. Because 30 degrees plus 60 degrees is equal to 90 degrees.
Ma'am, but they're not attached. Like usually,
No, they need not be. They can be two different angles.
okay.
Or they can be in the same figure. The angle can see, like, if you have an angle like this. Suppose there's an angle here. Okay, this angle is say 15 degrees. And suppose this angle is 75 degrees. Okay. Now what is 75 degrees plus 15 degrees? 90 degrees. So here also these two angles are complementary angles.
Yeah.
If you add, see, the angles can be two separate angles. See, now separate, I mean, like for 30 degrees, this is the vertex. But for 60 degrees, this is the vertex. The two angles, they have different vertices. The two angles have different vertices. Yeah. Okay. Now here, these two angles have different vertices. That is okay. This is an angle which measures 30 degrees. This is an angle that measures 60 degrees. 30 plus 60 is 90. So these two angles are complementary. Here what you see is, in this figure, both the angles have the same vertex. The vertex for 15 degrees is A. The vertex for 75 degrees is also A. That's okay.
Okay, ma'am. Okay.
There is one angle which measures 15 degrees. There is another angle which measures 75 degrees. Now, when I add them, I'm getting 90 degrees. So these two angles are complementary angles.
Okay, ma'am. I understand.
So the two angles can have the same vertex or may not have the same vertex. Is that fine?
Yes, ma'am. It's fine. Yeah.
Avanish?
Yes, ma'am.
Anirudh?
Yes, ma'am.
Harini?
Yes, ma'am.
All right. Now, Harini, in the next figure, are the two angles complementary in the next figure? What is 65 plus 35, Harini?
No, ma'am.
What is the sum?
10, 5 plus 5, 10, 0. 6 plus 3, 9 plus 1, 10, ma'am. 100.
Yes.
No, ma'am.
No, they're not complementary. Very good. Yeah. Anirudh, answer the first question.
Ma'am, can two acute angles be complement to each other? Ma'am, one acute angle measure is 30 degree, ma'am. So 30 degree plus 30 degree is 60 degree, ma'am. And to be complement, it is to be 90 degrees, ma'am. But it is 60 degrees, so they cannot be complement, ma'am.
No, they're not. Can two acute angles, meaning two different acute angles. Why you're taking the same? You need not take the same thing. Okay, I'll give you an example. 45 degrees is an acute angle. 45 degrees is an acute angle. It's 90. So two acute angles can be complementary.
Oh, ma'am, then what is the measure of from acute angle? What is the measure, ma'am? Till 90 degree.
Yeah, an acute angle, yeah, any angle more than 0 degrees but less than 90 degrees is an acute angle.
Okay, ma'am.
Now, 10 degrees is an acute angle. 80 degrees is an acute angle. Now, their sum is 90 degrees. So, two acute angles can be complement to each other.
Understood, ma'am. Yeah, ma'am, I understood. Sorry, ma'am.
That's okay. The question is, if you take two acute angles, can they be complementary angles? Yeah, they can be. There are so many examples. Supposing there is one angle which is 25 degrees and another angle which is 65 degrees. Both of them are acute angles and their sum is 90 degrees. So yes, the answer for the first one is yes.
Yeah,
Second one, yeah. Now 1 minute before that, now tell me, do you all know what is a zero angle?
ma'am,
Angle is 0.
0 degrees. What's an
0
acute angle?
Ma'am, 30 degrees.
0 and below 90 degrees.
Greater than 0 degrees but less
But
than
less
90 degrees.
90 degrees.
Then right angle?
Ma'am, 90 degrees.
90 degrees. 90 degrees.
Equal to 90 degrees. Equal to 90 degrees. Okay, obtuse angle?
90 degree to 180. 90 degree to 180 degree.
Correct. Greater than 90 degrees, but less than
180.
180 degrees. Then what is a straight angle?
Ma'am, 1 is equal to 180 degrees.
Correct. Straight angle is equal to 180 degrees. What is the reflex angle?
Greater than 180, lesser than 270.
360 degree, ma'am.
But less than?
270.
degree.
Who's saying 270?
Ma'am, me Navneet.
No. Not 270. Greater than 180, but less than 360 degrees.
Okay, ma'am.
350 degrees is also a reflex angle.
Oh, okay, ma'am. Yeah, sorry.
And what's a complete angle?
Ma'am, 3 is equal to 360 degrees.
360
degrees. 360 degrees. Okay, so zero angle is equal to 0 degrees. Acute angle is greater than 0 degrees but less than 90 degrees. Right angle is equal to 90 degrees. Obtuse angle is greater than 90 degrees but less than 180 degrees. Then straight angle is equal to 180 degrees. Reflex angle is greater than 180 degrees, but less than 360 degrees. And a complete angle is equal to 360 degrees. Those who are not sure about this can take a picture. Take a screenshot. If you're not sure about these, take a screenshot and learn it up.
No, ma'am.
Now the next question. Can two obtuse angles be complement to each other? Can two obtuse angles be complement to each other?
Ma'am, no, ma'am.
No, ma'am.
No.
Okay. Because what is the measure of an obtuse angle? It's more than 90.
More
One
than
angle
90
is
One more than 90 degree, less than 180 degree.
180.
yeah,
Yeah.
yeah. So when you take one obtuse angle, that itself will be more than 90 degrees.
Yes,
Then
ma'am.
if you take another angle which is more than 90, how will their sum be 90 degrees? Because
Yes,
when you take one obtuse angle itself, the measure will be more than 90. Then how will two angles add up to 90 here? So can two obtuse angles be complement to each other? No, because obtuse angle measures more than 90. So two obtuse angles cannot be complementary to each other. No, this is yes. Then can two right angles be complement to each other?
No, ma'am, because one angle is only 90 degrees.
One itself is 90. Then how will two? See, when we say complementary angles, it's about two angles. You should add two angles.
And
It's
you
not
should
about.
get 180.
See, now you cannot say that 90 degrees. 90 degrees is the complementary angle. No. See, this 90 degrees, it's a right angle. 90 degrees is the right angle. You cannot write 90 degrees and say it is a complementary angle. Complementary angle is about two angles. One angle plus another angle should be 90. Those two angles are complementary angles. Can two right angles be complement to each other? No, because one right angle itself is 90. Another one 90. 90 plus 90 is 180. They are not complement to each other.
Yes, ma'am.
Now these questions you can answer. Yeah. Now the first one is which pairs of the angles are complementary? So 70 plus 20 is 90. So they are complementary, correct?
Yeah, ma'am.
Yes,
ma'am. Second one is no, ma'am.
Yeah.
It's 100, ma'am.
Yeah, correct. Third one?
Not, ma'am.
No, ma'am. 100.
It's also 100.
Yes, ma'am. Yes,
And
ma'am.
yes,
Both, ma'am.
ma'am.
Yes, ma'am.
Yeah.
Complement.
So when you add these two angles, it is 90 degrees. So this is possible. This one is 100 degrees. This one is,
This one is
also
also
100
100
degrees. This one
This
is
one is
90.
90.
So 1 and 4 are complementary. 2 and 3 are not complementary. Now, what is the measure of the complement of 54 degrees? So the complement of 54 degrees will be 90 minus 54, which is 46 degrees.
36.
36, 36. Sorry. I'm just answering one question. Okay. So the heading is, what is the measure of the complement of each of the following angles? Complement of each of the following angles. So the complement of 54 degrees is 90 minus 54, 36 degrees.
Ma'am, next one is 49 for 41. 41 degrees.
Okay. So how do you find the complement? 90 minus the given angle. 90 minus the given angle will give you the complement. Now what are supplementary angles?
When two angles come together and become 180 degrees.
Yeah, if the sum of the two angles is 180 degrees. If the sum of two angles is 180 degrees. Sorry. Yeah, if the sum of two angles is 180 degrees, then the two angles are called supplementary angles. Again, supplementary angles is only about two angles, not one angle. You cannot, if one angle is 180 degrees, you cannot say that that angle is a supplementary angle. No, supplementary angles is about two angles, not three also. Exactly two angles. Exactly two angles. When you add these two angles, the answer should be 180 degrees. Then the two angles are called supplementary angles. So here 60 plus 120 is 180 degrees. Supplementary angles. These two angles are supplementary angles. When you add this and this, how much you get?
180, 180.
180. So they are supplementary angles. When you add these two, 180 supplementary
180.
angles. When you add these two,
190 will come, so they are not.
180 only. Add properly. 135 plus 45 is 180.
Oh, yes, so, yeah.
Yeah. Now these two angles have different vertex. They have different vertex. They have a different vertex. That's okay. There are two angles. Whether they have the same vertex or different vertex, there are two angles. And they add up to 180. So they are supplementary angles. Now you can also have angles like this with the same vertex. Supposing okay, so you can see one angle is here and this angle. Supposing this angle is 110 degrees and this angle is 70 degrees. 110 plus 70 is 180. 110 plus 70 is 180. Their sum is 180, so they are supplementary angles.
Okay.
Now, Harini, which is the vertex for the two angles? Name the vertex of the two angles.
R Q P.
No, vertex. From where do the from where do the rays start off?
Ma'am, from Q, ma'am.
Q. So Q is called the vertex. Q is called the vertex of the two angles. Yeah, now you wanted to name this angle. Name this angle, Harini.
I can't understand, ma'am.
No. How do you name now? 110 degrees. Name this angle. What is the name of this angle which measures 110 degrees? Put the vertex in the middle. Vertex Q, put it in the middle. How do you name the angle?
RQP, ma'am.
RQP. RQP. All or
PQR.
PQR. PQR is 110. How do you name 70 degrees angle?
SQP.
SQP is equal to 70 degrees, or you can call it angle
PQS.
PQS is equal to 70 degrees. Very good. Yeah. Harini, answer the first one. Can two obtuse angles be supplementary? Tell me one obtuse angle. Yeah, children. Okay, class, can two obtuse angles be supplementary?
No, ma'am.
No, ma'am.
No, because both the angles will be more than 90. So their sum will be more than 180. See,
Yes, ma'am.
one angle is more than 90 degrees. The other angle is also more than 190 degrees. So their sum will be more than 180 degrees.
Yes, ma'am. Because when we add even 91 plus 91, it will be 182.
Yeah, correct. Correct. Can two acute angles be supplementary, children? One angle is less than 90 degrees. The other is also less than 90. Then
No,
the sum
ma'am.
will be less than
No.
180 degrees.
No, ma'am.
No, it's not possible. Two acute angles also cannot be supplementary. See, I'll come from the beginning. Obtuse angles. Obtuse angles means more than 90 degrees. More than 90, more than 90. So when you add two obtuse angles, their sum will be more than 180 degrees. So they cannot be supplementary because it will be more than 180. Now acute angles, the next one. Less than 90 degrees. less than 90 degrees. Both are less than 90. So when you add, their sum will be less than 180 degrees. So they are not supplementary. You can even take examples like you can take 89 degrees. 90 is right angle, so acute angle 89 degrees and another 89 degrees. 9 plus 9, 18, 18, 8, 1 carried over, 16, 17, 178. Can two right angles be supplementary, children?
Yes, ma'am. 90
No,
plus 90.
ma'am.
Oh, yes, ma'am. They can't.
Yes,
They can.
yes, ma'am. Yes,
Yeah.
ma'am. 90 plus 90.
Yeah. So one angle is 90 degrees. Another angle is also 90 degrees because both are right angles. Both are right angles. So like angle ABC is 90 degrees. There's another angle PQR. That is also 90 degrees. When you add these two, you get 180. So angle ABC and angle PQR are supplementary angles. Answer the last one. Can one acute angle and one obtuse angle be supplementary? One acute and one obtuse.
Yes, ma'am.
Sorry, 1 second. Yeah. So one angle is acute, say 70 degrees. The other one is obtuse, say 110 degrees. So 110 degrees is an obtuse angle, 70 degrees is an acute angle,
Yes, ma'am.
and
Yes,
their sum is 180.
Yes, ma'am. They can be. I told.
Now one acute angle, 50 degrees. One obtuse angle, 130 degrees. Their sum, 180 degrees. So an acute angle plus an obtuse angle can be supplementary. Can be supplementary. It is possible. You can give many examples. One acute angle and one obtuse angle. They are not always supplementary. It's not that they're always supplementary. No, no, no. They can be. The question is, can one acute angle and one obtuse angle be supplementary? Can it be supplementary? Yes. That doesn't mean that they're always supplementary. Because if you take the acute angle 10 degrees and the obtuse angle 100 degrees, 100 is obtuse, 10 is acute. What is their sum? 110 degrees. They are not supplementary. You can give examples of one acute and one obtuse which are supplementary. But that doesn't mean that every time you take examples of one acute and one obtuse, they will always add up to 180. That is not possible. That is not always true. Okay, so these you can answer. Find the pairs which are. Yeah, Avanish, answer this question. What is the supplement of 125 degrees?
Ma'am, 180 minus 125, ma'am.
180 minus 125. How much is that?
1 second, ma'am. 155, ma'am.
55 degrees. Okay. So the supplement of 125 degrees is 55 degrees. Yeah. Anirudh, what's the supplement of 90 degrees?
125 degrees. Oh, sorry, ma'am. I thought the third one. Actually, it's 90 degrees.
90 degrees. The supplement of 90 degrees is 90 degrees. Navneet, are these two angles supplementary?
No, ma'am. No.
This one? No. Harini,
Yes.
these two angles are supplementary? Are these two angles supplementary, Harini?
Ma'am, once again, ma'am.
Yeah.
No, ma'am.
No. Harini, do these two angles have the same vertex or different vertices?
Um, different, ma'am. Different.
You're not sure. Avanish, this angle and this angle, do they have the same vertex or different vertices?
Ma'am, different, ma'am.
Different. Because this is the vertex of the angle which measures 105 and this is the vertex of the angle that measures 65. They have different vertices.
This one.
Okay. Next is adjacent angles. So now from the beginning, we have seen what is the point, line, line segment,
And line.
ray, collinear points, non-collinear points, supplementary angles, complementary angles. Now adjacent angles. Adjacent angles. Now what are adjacent angles? Now angles, if two angles have a common vertex, a common arm, and if their non-common arms lie on either sides of the common arm, then these two angles are called adjacent angles. Let me just draw a figure for that. Now, how do you name this angle, children? How do you name this angle? Angle
Angle BAD. BAC.
BAC. This is angle
Yes.
BAC. What about this angle?
Angle CAD
CAD.
or DAC.
Okay.
This one.
DAC or CAD.
CAD. Yes, ma'am.
And this one is BAC or
Or
CAB.
CAB.
Okay. Now, let's understand if these two angles are, now here we have two angles, angle BAC and angle DAC. BAC and DAC. We have two angles, BAC and DAC. Now we are trying to understand if these two are adjacent angles. If these two are adjacent angles. Okay. Now check the first condition. They must have a common vertex. Yes, both of them have the same vertex A. You can see it in the name of the angle itself. A is in the middle. A is in the middle. So they have the same vertex. BAC, DAC. Both of them have the same vertex A. Yes or no, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now, which are the arms of angle BAC? Which are the arms of angle BAC?
Ma'am, BA.
Ma'am, B line and C line, ma'am.
Very good. So AB and AC. AB and AC. AB and AC are the arms of this angle. And what are the arms of this angle?
AC and AD.
AC and AD. Now the arms of this angle are AD and AC. And of this angle are AB and AC. So both the angles have a common arm AC. Both the angles have a common arm AC. So the second condition is also working. They have a common vertex A. They have a common arm AC. Now, if this is the common arm, then this one and this one are the non-common arms. These two are the non-common arms. These two are the non-common arms. And where are they? They are on either sides of the common arm. See, the common arm is here. The non-common arms, one is on this side, the other is on the other side.
Yeah.
So in this figure, The two angles are BAC and DAC. The two angles have the same vertex or a common vertex A. They have a common arm AC and their non-common arms AB and AD. They lie on either sides. That is one arm is on this side, the other is on the other side. Their non-common arms lie on either sides of the common arm. So such angles are called adjacent angles. Adjacent angles. Adjacent angles is also about two angles. Is also about two angles. Two angles are said to be adjacent angles if they have a common vertex, they have a common arm, and their non-common arms. They lie on either sides of the common arm. Now let's take a question to understand. Now look at the first figure, children. Look at the first figure. Can you see the angles 1 and 2? Now tell me for angle 1, tell me the arms of angle 1. I'm talking about arms of angle 1. No, 1 minute. First we'll write the vertex. Which is the vertex of angle 1?
O.
Is O. Which is the vertex of angle 2?
I'm saying O.
O. So they have a common vertex. Angle 1 and angle 2, they have a common vertex. Now let's talk about the arms. Arms of angle 1. Arms of angle 1. Which are the arms of angle 1?
Ma'am, AOB, ma'am. Angle AOB.
No, arms.
OA and OB, ma'am.
Correct. Ray OA and ray OB. Correct?
Yes, ma'am.
And which
Yes,
are the
ma'am.
arms of angle 2?
Ma'am, Ray OB.
Ray OB and
OB and OC, ma'am.
OC. Ray OB and OC. See, they have a common arm. Both of them have a common arm, OB. Now, these two are the non-common arms, OA and OC. The remaining two, which you see here, they are the non-common arms. And no, 1 minute, I have not finished. These are the non-common arms, OA and OC. Where is OA? This is the common arm OB. Where is OA? On one side, on this side. And where is OC? On the other side. So these two angles 1 and 2 have a common vertex O. They have a common arm OB. And the non-common arms, that is the other two arms, they lie on the opposite sides or on either sides of the common arm OB. Yes, Avanish, watch it out.
No, ma'am. No, ma'am, it's me, ma'am.
Yeah, Anirudh, yes.
Ma'am, I thought you were talking about the second diagram, ma'am. Like, is it the first diagram you're talking about?
No, in this slide, I just finished the first one. This one.
Oh, okay, ma'am.
Okay, we'll do it again with you, Anirudh. Now for the first figure.
Yeah.
Yeah, tell me the vertex of the two angles. Which is the vertex of angle 1? Which is the vertex of angle 1? Which is the vertex of angle 2?
Oh.
Okay.
Ma'am, angle.
Sorry?
Ma'am, angle 1 includes AOB and angle 2 includes AOC, like that?
No, vertex is from where the rays start off. All the rays, OA, OB, and OC, all of them start from O, no?
Yeah, ma'am.
Yeah, so the vertex of angle 1 is at O because OA and OB, the rays, they start from O.
Oh, okay, ma'am.
And for angle 2, the arms are what? OB and OC. Again,
Yeah,
OB and OC, they start from O only.
Ma'am, and B is common, so in the left side and right side, the other two angles are not common, ma'am. Yeah, ma'am, understood.
Yeah. So the common, what are the arms of angle 1? Arms of
Ma'am,
angle 1 are
OA, OB.
OA, ray OA and ray OB.
Yeah,
Which are the arms of angle 2?
ray OB, ray OC.
OB and OC. OB and OC. So you can
Yeah.
see OB is common. And the
Yeah,
other two arms, OA and OC,
different.
they lie on either sides. That means opposite sides of the common arm. The rays OA and OC, one lies on this side of the common arm, the other lies on this side of the common arm, either sides of the common arm. So angle 1 and 2 form a pair of adjacent angles.
Okay,
Because
ma'am.
because they satisfy all the conditions. They have a common vertex, they have a common arm, and their non-common arms lie on either sides of the common arm. So they are adjacent angles.
Yeah.
Now we'll do 3. We are doing figure 3. Figure 3.
Okay.
Yeah. Now tell me the vertex, all of you. Vertex of angle 1.
Ma'am, P.
P. Vertex of angle 2.
O.
Do they have a common vertex?
No, ma'am.
No,
They
that's
don't.
what. So don't check the others. If they don't have a common vertex, don't check
They're
others.
not adjacent.
They are not adjacent angles. Angle 1 and angle 2 are not adjacent angles because they don't have a common vertex. So they are not adjacent angles. Adjacent angles must have everything. All this should be there. They should have a common vertex. They should have a common arm. And their non-common arms should lie on either sides of the common arm. All these 3 conditions should be true. So we are checking the first one, vertex. Vertex of angle 1 is P. Vertex of angle 2 is O. There itself, they fail. They are not adjacent angles because they don't have a common vertex. Correct?
Yeah.
All right. Yeah. Yes. Now coming to linear pair. 1 second. Yeah. So now what do we mean by linear pair of angles? What do we mean by linear pair of angles?
Ma'am, can I say?
Okay. No. I'm going to tell you. So linear pair. So when we say linear pair, they have to be adjacent angles. Only adjacent angles can form a linear pair. Remember that. Only adjacent angles can form a linear pair. So a linear pair is a pair of adjacent angles whose non-common arms are opposite rays. One ray will go in this direction, the other will go in the opposite direction. Now in these figures, they did not go in the opposite direction. See here, in this figure, see, like if one ray goes in this direction, the other one should go in the opposite direction like this. Like in this figure, see here, this is the common arm. OR is the common arm. OR is the common arm. The non-common arms OQ and OP, you can see that if OQ is going in this direction, OP is going in the opposite direction. Now these two angles are adjacent angles and they form a linear pair because their non-common arms are going right opposite to each other. If one is traveling towards east, the other is traveling towards west. Opposite directions. So two angles, two adjacent angles form a linear pair. Two adjacent angles form a linear pair if their non-common arms are opposite rays. So see here, see in this figure, angle 1 and angle 2. They are adjacent angles. Why they are adjacent angles? Because they have the common vertex O. They have a common arm. Both angles 1 and 2, they have a common arm OC. Their non-common arms are OB and OA. They are the non-common arms. And see how they are traveling. If OB is going towards east, OA is going towards west. They're going in opposite directions. So here angle 1 and angle 2, they are adjacent angles and they form a linear pair. Because their non-common arms are opposite rays. Because their non-common arms are opposite rays. But look at this figure. In this figure, angle 1 and angle 2. Look at angle 1 and angle 2. Angle 1 and angle 2, they have a common vertex O. They have a common vertex O. They have a common arm OQ. Yes, they have a common arm OQ. Now, which are the non-common arms? OP and OR. OP and OR. These are the non-common arms. Now, look at the non-common arms. If OR, if this one is say east, if OR is going east, OP should go west. But see where it is going. It's going northwest. This is north and this is west. This is going between north and west. It's going northwest. So they're not going in the opposite directions. So here angle 1 and angle 2, they are adjacent angles, but they don't form a linear pair. Here 1 and 2 are adjacent angles, but they don't form a linear pair because their non-common arms OR and OP, they are not going in the opposite directions, east-west, north-south. They're not going in the opposite directions. If this is going towards east, this one should go like this. No, it's not going like that. It's going like this. So they are not going the opposite direction. So they don't form a linear pair. But they are but they are adjacent angles. They are adjacent angles. Because they have a common vertex and a common arm. And their non-common arms, they are not going in the opposite directions. So they don't form a linear pair, but they are adjacent angles. And if two adjacent angles form a linear pair, they are supplementary. So see here in the first figure, angle 1 plus angle 2 is equal to 180 degrees. Because if it is a linear pair, then the sum of the two angles is equal to 180 degrees. Because it's a straight line. This is a straight line. The rays are going in the opposite directions. The non-common rays, the non-common arms are going in the opposite direction. So it will make a straight angle, 180 degrees. Straight angle, 180 degrees. So in this figure, angle 1 and angle 2, they are adjacent angles. Angle 1 and angle 2, they form a linear pair because OB and OA, they are going in the opposite directions. So they form a linear pair. And because they form a linear pair, angle 1 plus angle 2 is equal to 180 degrees. Because they form a linear pair, their sum is equal to 180 degrees. Now, this is your homework. Take a picture of these questions and answer them. We'll discuss in the next class.
Okay, ma'am.
Yeah.
Okay.
Yeah, all of you take a picture.
Ma'am, I took screenshot.
Whatever.
Yeah.
Okay.
Yeah.
Anirudh and Harini, done?
Ma'am. Yeah, ma'am.
Yes, ma'am.
Okay. So now, Anirudh, tell me from the beginning the different terms we came across in this chapter, lines and angles.
Ma'am, we
Tell me in the order, in the same order. First one.
Ma'am, like what is angles? What are the different parts like that?
No, not like that. Okay, who can answer my question?
Ma'am,
Organize.
Ma'am,
Okay, now
yes. Yes, ma'am. Point, line, line segment, collinear pair, non-collinear pair, adjacent.
No, one second. Point, line segment, ray.
Ray, Collinear, non-collinear.
1 minute. Collinear points, non-collinear points.
Collinear points, non-collinear points, adjacent angles, and
No. What is the next one, children? Avanish, what after that? Non-collinear points, then complementary angles, supplementary angles.
Supplementary angles, then adjacent angles.
adjacent angles and linear pair.
And
Linear
pair.
Very good, linear pair. Very good, children. Very good. So, children, I'll share the note. This one is a very old presentation which I used today. It's a very old one. I made this in 2020. I have to change the presentation. That's why I did not ask you to write the pictures and all that. No, they're not very clear. I have to change the presentation. That's why I didn't ask you to write anything. I'll change the presentation and I'll give you further instructions on WhatsApp. All right.
Okay, ma'am.
Yes, ma'am.
Now, Harini